Hello everyone. Today we are going to start our session with the application of eigenvalues and eigenvectors. So we have to start our session at the type 4 application, that is eigenvalues and eigenvectors via design thinking by a network analyzing problem. We have to introduce the type 4 problem and design thinking, that is eigenvalues and eigenvectors satisfying the equation A V equal to lambda V for a square matrix A. By type 4 problems, applying eigenvalues, eigenvectors to the real world scenario, that is the for example network analyzing. Design thinking stages, there are following design thinking stages we have to utilize, that is empathize, define, ideate and prototype, test. So we will solve a network influence problem using 3x3 matrix. First thing is empathize, understand the uses. So analyze the study influence in a small network. That means the content is the directed graph with 3 nodes and edges represent the influence. So we have to reach the goal, use eigenvalues and eigenvector to identify the most influenced node. Next, the problem statement that conclude the define, including define. Second stage, define. So the problem statement is find the eigenvalues and eigenvectors of a adjacency matrix of 3 node in a directed graph by A equal to 0 1 1 1 0 0 0 1 0, that is Aij equal to 1 if node I is influences node j, otherwise 0. So the condition is, first thing, Aij equal to 1 if the node influence to j, I node influence to node j. That dominant eigenvalue and its eigenvectors indicate steady state influence distribution. Next thinking is ideate. Compute eigenvalues to find dominant one, that is largest magnitude of the given dominant. So finding the corresponding eigenvectors to rank node influence. For example, power method. So we shall compute the large network, visualize the eigenvector as influence scores for each node. Next one is prototype. By step 1, form the characteristic equation. So solving the characteristic equation, it means determinant of A minus lambda I equal to 0, where I is the identity matrix described as 1 0 0 0 1 0 0 0 1. Compute A determinant of, we have to find determinant of A minus lambda I, but we have to compute A minus lambda I is equivalent to minus lambda 1 1 1 minus lambda 0 0 1 minus lambda. So A is the given matrix. A is the given matrix. From given matrix A minus lambda I we have to compute. Next thing is compute step 2, compute the determinant. So calculate determinant of A minus lambda I equal to determinant of lambda minus lambda 1 1 1 minus lambda 0 and 0 1 minus lambda. Expanding the third row, so determinant of 0, expand this third row, that is cofactor is minus lambda into lambda squared minus 2. Set this becomes 0, so minus lambda squared minus 2 equal to 0. So solving this equation we get the lambda value, therefore lambda equal to 0 and lambda equal to root 2, lambda equal to minus root 2. The eigenvalues are lambda equal to lambda equal to lambda 1 is root 2, lambda 2 is minus root 2, lambda 3 is 0. So the dominant eigenvalue is lambda 1 because positive eigenvalue, that is the maximum value. Root 2 is proportional to 1.414, that is the largest magnitude. So step 4, eigenvector for lambda equal to root 2, what is we have to determine the eigenvector, that is a minus xi, that is x is the lambda I. So this is the conclusion, eigenvectors. So eigenvectors x, y, z, x equal to 2, y equal to root 2 and z equal to 1. By choosing z equal to 1. So to dominant eigenvalue lambda equal to root 2, similar to 1.414. The corresponding eigenvectors to root 2, 1. So this represents influence curves. Node 1 is 2, that is node 1 is 2, node 2 is root 2, node 3 1. So node 1 is the most influential, followed by node 2, then node 3. So application prioritize the node 1 for marketing or information dissemination. Thank you.